let's get mechanics of rigid bodying. Let's
Exactly.
go.
Mag-ano? Basta Gina. Okay. Wait lang. Wait lang. The connection is kinda laggy pala. Oh my god. 15 minutes of silence, hindi ko naayos yung sync. What? 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 Hold on. I'll just repair it. Oh my god. I'm so sorry. How do I repair this? Any Rami. Hello. My flop era. Why are there suddenly people pag nagte-technical difficulties ako? Eme, thank you for coming, guys. Hold on. Let me
Ano
restart
yan,
that. Oops.
choreographed stalling yan. Kasi like Jerome sensed na you guys would arrive a few minutes late. So, intentional yan for you guys though.
Ano daw?
100%.
There. Is it
But yeah,
okay?
thank you
That's
guys.
good enough.
We understand that it's a bit early. Pero kasi, if we have to do once per week, mas medyo gipit din if we do it next week. Kasi your review sessions are either Thursday, Friday, or Saturday. So,
Okay.
don't have much of a choice. Pero, thank you pa rin for being here.
Real na. Are we still recording? G? Yes? Joey? Okay, okay. So, welcome back, guys, from the Ang Week after party. um, Ayan, let's just start. So, this is in the rain box. I just typed it out because I don't really like the handwriting of the guy who wrote it. Anyway, so you decided to have a wild ride in a carriage in an amusement park with its starting point at a certain height above the ground, shown by points in the figure on the right. Your feet are freely hanging above ground, and your slipper ended up flying off the carriage right when your ride started. The carriage started to drop at 40 meters below the starting. Huh? The carriage started to drop, and at 40 meters below the starting point, denoted by point B, the carriage already had a downward velocity of 20 meters per second. It was also observed that when the carriage was at the same point, your slipper was moving away from you at a velocity of 18 meters per second, 80 degrees below the horizontal, with the said velocity measured with respect to the carriage. Find the time it takes for the carriage to travel from the starting point to point B. Find the velocity of the sandal right when it started flying off the carriage. Um, I just want to say I feel like all of these problems are a bit easier than some of the things that we've done in class, so I hope it will be enough for us. Anyway, so something to start off with. Let's just draw like what's happening here. So A, point B. Then at point B, the velocity is 20 meters per second downward. And then here at point B, there's also this flipper with 80 meters per second, 80 degrees below the horizontal. One thing that I noticed is there's a missing assumption here. Like I think maybe the person forgot to write it, or the question is just bad. Anyway, so we just have to assume that like the carriage has constant acceleration downwards, because like that's the only way we can solve it with what we have right now. Woo. Hold on. Mag-landscape na lang ako. Okay. Acceleration. So, um, this one is still simple. Like, I feel like kaya din natin if we were still in physics 71, kinda. So, let's just list down our kinematic equations first, like the basic ones. So, this one, D naught. I hope you guys memorized this already because it won't be given to us this time. So, final destination, final distance, displacement, displacement or distance is equal to initial position. Ah, yeah, basically final position equal initial position plus initial velocity plus 1/2 acceleration d squared. And then out of the thing, what do we know here? We know that vi equals 0, d naught equals 0, d equals 40 or -40 in this case. Um, sa science lang, just be careful. You don't need to be strict with it as long as consistent. So let's just make downward negative so that we don't make a mistake. The acceleration, you might be tempted to assume that it's due to gravity, but like wala namang sinabi. And it's a amusement park ride, so it's not like it's still like controlled, so not necessarily gravity. So we don't know the acceleration, and we also don't know the time of fall. So we have two unknowns here. So that means we still need another equation to get our life together. So since we're given the distance and then uh the oh yeah, sorry, I forgot to write. We also know the final velocity, 20 meters per second. Or let's just make that v prime. Ah wait, no, sorry. Kahit final. Ibang item pala yung inisip ko. Okay, so let's make that final velocity, 20 meters per second. So we know initial velocity, final velocity, and then the distance that it traveled. So there's another equation we can use. Vf squared equals vi squared plus 2ad. And then this one, yeah, we know this one, we know this one, we know this one. You can just plug everything in to find acceleration. So if you plug in all that, um, fine, I'll write it out because I am so kind. Um, 20 meters per second squared equals 0 plus 2a times, um, let's just make that 40. It doesn't need to be -40 because like it's basically like the distance traversed. So it traveled 40 meters. I mean, even though it was downward, it was just 40 meters. And like, another thing is we really just can't make it negative because I'm magiging negative square root siya, or square root of a negative. So do a times 40. And then if you just solve that, it's going to say that a is equal to 5 meters per second squared. And then now that you know a, we can plug it into this one to find the time that it took since, that's what they're asking us, find the time it takes for the carriage to go from A to B. So plug everything in that we know into this one. So go to -40 equals, oh, okay, kaya natin to. Equals, so D naught is 0, then plus 0 again. And then in this case, since we know that it's, oh, is there a chat? Do I need to look at this? Okay, well, I think that was not the notification, but I just saw his chat. Anyway, so let's make it -1/2 80 squared. I know that like what we calculated here is positive, but like from this equation, because since pure square siya, I think, not necessarily, but like in our case right now, negative, this is a downward acceleration since, ayun nga, the context of the problem. We exist in the context of all in which we live and what came before us. Anyway, oh, sorry, I forgot to substitute. Okay, so this would be 5t squared. If you just solve for that, you're gonna get t equals 4 seconds. And then let's add the correct sig figs or else maminisan kaya. Um, reminder lang na sig figs in ES 101. I think some people don't always remember it's 3 sig figs and then 4 if it starts with 1 because ewan ko. They're just quirky like that. Okay, sub item B. Find the velocity of the sandal right when it started flying off the carriage. So we already know this 18 meters per second, 80 degrees, 80? Yeah, 80 degrees below the horizontal. Oops, 80 degrees below the horizontal. But this is the velocity of the slipper with respect to the carriage, v prime. So if you guys remember that, like, in general, the velocity of A given B is equal to like the velocity of A minus velocity of B. So since we also know the velocity of the carriage at the end, we can find the velocity of the slipper at the end. Oh wait, sorry. Medyo nag-skip over. Um, because the question in general, is asking find the velocity of the sandal right when it started flying off the carriage, but yung given satin is like at the bottom, so like it's been a while. So like the situation here is like this is where it started, and like when they say it's flying, like their implication is that like it's a projectile. Well, projectile motion. Pretend that's parabolic. So we don't know like how the start of its thing was, but yeah, we know how it was like at the bottom. And that's the neat thing about projectile motion is since it's like it's parabolic, usually if you get information about a certain thing. So with enough information you can get to any point in its trajectory, which is what I like about projectile motion. I don't get why people hate projectile motion. Anyway, that's a tangent. So basically, the goal right now is we're gonna get the velocity of the slipper at the bottom, so that eventually we can reach the velocity when it started launching. So where was I? So the velocity of the slipper is equal to the this one, 18 meters per second. Woo. And then you just wait long. I'm doing what is algebra, bro? Okay, sorry, I have to write it out. Vs minus Vc. So Vs equals Vs of relative to C plus Vc. Okay, so we're just gonna plus this. What did they give us again? 20 meters per second downward. Okay, so you can just split this into like, oh, actually, okay, so let's split this into its x and y. I'm just gonna try to make this like a bit more concise. I'm not sure if our props will appreciate writing the solution this way. But so let's just make this 18 cosine 80, and then negative 18 cosine 80 minus 20, and then ayun nga. So you get square root of those. Cosine 80 squared plus 18 cosine 80 minus 20 squared equals, oh, I have no space. Okay, equals 37.9 meters per second. Okay, sorry, let's put this apostrophe because this is at the end. All of these should have apostrophe, like V prime. Keme keme. Did anyone chat anything? Okay, no. Then for the angle, let's just get tangent of um y over x. Sorry, I'm not gonna write it all over again, but you guys know what y and x are. Um, but since we know that our y is negative and our x is positive, so it looks something like this. So if you do arctangent of y over x, your angle is gonna be somewhere here. So when you do that, and yes, okay, when you do that, you get 85.3 degrees percent degrees, girl. Okay, degrees. And then, like I said, the thing is here. So this is the VS prime. Oh, Lejo. VS prime. is equal to 37.9 meters per second, 85.3 degrees. So this is at the bottom. So bale. At this point, it's Vs prime. And we know na with projectile motion, like the only forces or like the only accelerating on it is gravity. So that means like even here at the start, Vs, Vsx is gonna be okay, let's write this somewhere else. Para maayos. So because projectile motion, Vsx is gonna be equal to Vsx prime. And then Vsy is gonna be Vsy prime minus. Um, if wait, sorry, plus because we're treating this as a negative velocity goes downwards. So plus 9.8 times the time that the carriage was falling. Are we following? Medyo a lot of things got explained. So if someone wasn't able to follow, just feel free to ask me to like elaborate more. I mean, this comes from another kinematic equation, which honestly, like, you don't need to memorize it that much because it based on talaga siya sa like definition of acceleration and velocity, which is like since Vf equals Vi plus At, then we just switch these two, not switch these two, transposed. Eh? Ay. Medyo magulo yung signs, but if you like work it out yourself, you will know that it's consistent. Okay. So first of all, we already know that VSX in this case um is 18 cosine 80. So let's just solve for VSY. It's gonna be 18 negative 18 cosine. Huh? Sorry, I wrote something wrong, but like the answer is still correct because I was just copying it off the answer key. This is sine. Wow, guys, why is no one pointing that out? Okay, so that's 18 sine 80, 18 sine 80, 4 because it's like the y component. Okay, so 18 sine 80, and then minus 20, and then my add pataya plus. So that's why I was saying how like the signs are still adding up. Because like negative na siya, and then plus because like we want to go back to when it wasn't as negative as it is right now. Gets niyo ba ako? Gets niyo ba ako? Anyway, 9.8, 9.81 pala yung convention, not 9.8. And then the time, we didn't just steal the time from letter A, which is 4. So from this, you're gonna get something like 1.513. So we just do the same thing. So the initial velocity of the slipper, 18 cosine 80 squared plus 1.513 squared. You're gonna get this three, okay, 3.47 meters per second. Then tangent gonna be equal to y over x. This time we have a positive y, positive x, so it's gonna look like this. The angle is here. So whatever you get here, that's where you're gonna say that's what you're gonna draw. So ito yung 25.8 degrees. So easy, right, guys? Um, so yeah, that's like the whole problem one na. Um, if there's any questions, go lang. Um, I will like wait 30 seconds to let it sink in. Let that sink in. We Gucci. Gucci. Dolce and Gabbana. Na, 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 na. home, smell home. Okay. I hope you like the commercial break. I think we're ready to move on. So, ito yung mas mahirap. Well, di rin siya mahirap eh. But okay, let's go. Let's go. So, a spring mass pulley system shown on the figure on the right illustrates how the 5 kilogram block A and the 10 kilogram block B are connected to each other by ropes and pulleys. A pulley is fixed on the edge of a rough surface that block A slides on, and the same block is connected to a spring with K equals 20 Newton per meter that is fixed on the wall. A pulley is fixed on the side of block A, which is opposite to the side attached to a spring, and this pulley has the lower rope segment attached to the center of the other pulley fixed on the edge of the rough surface, while the upper rope segment is then connected to block B using the same pulley fixed on the edge of a rough surface. Given that the rough surface has frictional coefficients mu k equals 0.15 and mu s equals 0.2, find the velocity of block B at the instant when block A has moved 50 centimeters, excuse me, to the right. Express your answer in meters per second. So, ang daming sinabi in like this part, but honestly, that's just like a word description of this picture. So, don't worry about that because you have eyes and there is beauty everywhere with for those with eyes to see something like that. Anyway, uh, let's write down. Let's draw free body diagrams because that's fun. Sometimes it's fun. Sometimes it's not. Anyway, so for A, let's start with A. We have the weight and the normal force. So normal lang siya dito. So up and down. Hooray! Then this is the potential friction force. I'm already assuming it to be to the left since in our situation, block A is gonna move 50 centimeters to the right. So friction goes against direction. Yeah, 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 yada yada. You should know that. um. Anyway, so here's the force due to the spring. Or actually, I'm not. Meron ba? Um. Wag na muna yan. Okay, wait lang. I will go back to that later. And then the tension here. So there's tutti, tutti frutti. Since there's like two ropes. And then let's do block B. Ah, okay. Yes. Anyway, so let's do block B. So this is just the weight, then the tension. So you know that like the weight is gonna be, the tension is gonna be equal to the weight. Well, actually, I don't know if we even need to use all that, but it's always good to picture our situation. Oh, ano, Loki di naman to need, but let's see as we go on. And then let's also list down our givens. Um, mu k equals 0.15, mu s equals 0.2. Um, so since there's like a spring, that's when we have to use like work energy. Unfortunately, not unfortunately, I like work energy. So let's first like uh, if you've been to my previous sessions, I always say, not I always say, I've said before, the first step is always to try. So pag ganito, or like if this is like even an even worse situation, don't I don't know, don't panic. Just take it one step at a time because it will become clearer as you go. So the first thing that we can do is list down or find the energies at the first initial state and then the state that we are going to find. So let's say first that the first state state one is the initial state. State two is block A slides 50 centimeters. So let's find the energies. More energy, more power. Anyway, so KE, GPE, EPE. If you guys don't know what that means, um, kinetic energy, gravitational potential energy, elastic potential energy for the string. But you should know what that means. Anyway, so at the start, they're both not moving, so zero on kinetic energy since velocity is a factor in that. Gravitational potential energy, zero for A. Then for B, um, depends where you set your datum. Datum. So actually, I should have drawn the situation. Uh, 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 um, gets man. Oh, that's so ugly. Anyway, let's just say our datum is like where B is right now. And like A and B don't have to have the same datum. Kasi, you know, I think it's pretty obvious. Not pretty obvious. Like, guess you know, like conceptually, A is already like sitting on the thing, so it doesn't have gravitational potential energy because it's already on the lapag. But B is nakalutang. So, instinctually, it should have um a non-zero gravitational potential energy. But technically, you could set the datum somewhere else, and then it would have gravitational potential energy, or like that even like you could set the datum somewhere else for A, and then it would have gravitational potential energy on both sides. But like magka-cancel lang din naman yun. So what's the point? Anyway, asking potential energy. I think a missing assumption of this problem. Ang daming incomplete ng nagsulat nito. Haba-haba pa naman. Anyway, other missing assumption is that the spring is like at rest, like it's not deformed. So we have to assume for na lang na the the elastic potential energy is zero for both. And then after block A slide to the right, um, both blocks will have moved na. So yung kinetic energies nila is one half of their mass times their velocity squared. These non-binary blocks. Anyway, then zero. And then for B, we can set the datum na lang to be, oh, wait lang, but di nag-update. Okay. The datum to be where it ends up. So we can just set it to zero since we believe that the datum is yung height na kung saan mag-end yung block B. So that is, yeah, that's the T. Anyway, so elastic potential energy for A, one half kx squared. Then zero for B because hindi siya yung connected sa spring. Gets niyo ba ako? Okay. So, uh since we have work energy, we just want to like plug into this like the conservation, the work energy cheme root. So which should be like T1 V1 plus V1 2 plus V2 plus V2. This term here is just like um work done by outside or non-conservative forces. Yeah. So if you guys don't know, gravitational energy um and like elastic are considered like conservative forces. I think yeah, I mentioned naman yun before. You guys know this. Uh so in this case, it's gonna be friction. Or work done by the friction is gonna be that term. So guys, parang ang tamlay ko mag-discuss right now. Let's cheer up. So uh we want to plug in all of this, but we actually don't know everything yet. Uh, I mean, plainly, we need to find out the VA and the VB squared. But then, how will we do that if we don't even know the H and okay, we know the X, but it's 0.5 meters, 50 centimeters. We don't even know the H, and like you might be tempted to say like, oh, it's connected by a rope, so H is just gonna be X. But apparently, nalaman ko lang kanina while looking at the answer key. And like this wasn't taught to us, so I don't know if there's gonna be something like this. But Good to know then. So, sorry, draw this ng maayos. Sorry guys, that's maayos na for me. Um, Jesus. Oop, oop, oop. Okay. So let's say block A moves a certain distance x. So to find out how far like block B is gonna move down, like I think a good way of parang picturing it is asking how much of this rope is gonna be loosened. Like yeah, how much of it is gonna instead of being here, it's gonna go there where block B is. So the thing is actually we have this. So the amount of rope that's gonna end up going down or like loosening is this. Oh, why did it stop? Hello? Audible naman ako na. Oh,
Oh,
oh.
yes, you.
Okay, we are fixing it. Fixing this diva. So, you guys can take this time to ask any questions. Ano ba yan? What's happening to the world? Yun. Hmm. Gee whiz, guys. Sh- This sure is a sticky situation. Bruh. There we go. Okay. So as I was saying, I don't know if nagpakita siya sa screen kanina, but uh, so when A slides a certain distance x to the right, you can visualize it as like actually this much rope is gonna be freed up, which is like um, it's not obvious and like hindi siya sakto in real life, but you know this isn't real life. Everything in ES 101 is like ideal, so this is just gonna be 2x. So actually for every unit x na nagsa-slide to the right yung A, um, 2x units of rope are freed up. So actually, bababa ang 2B, ang B by 2x also. So another way to write that is uh the change in x of A is equal, sorry, the change in y of B. I mean, same thing lang naman, is 2 times the change of x in A. You feel me? Yeah. Yeah. Okay. So keep this in mind. So since like naka-rope siya, this is when like we can sorry, naka-rope siya, so you know, hindi pwedeng like they don't really move at the same time. So you can also what's the word? Derive another equation from this na since for every change in for every change in XA, there's twice as much change in the height of Y. Actually, the velocity of B is twice the velocity of A. So now that we have that equation, we can plug in. Actually, these we have these two. We can plug in our stuff. But I'll write it out like plainly para clear. Um, so what is MBGL MBGH plus this one's gonna be mu K N frictional force times R D. So wait lang. I didn't write. I think Yeah, this is the equation for force done by a non-conservative, work done by a non-conservative force. So force, the dot product of force and the displacement. So you'll see later that actually since friction is in the opposite of the displacement, this is a negative term. Um, Equals, oh my God, 1/2 VA prime squared plus 1/2 MV, oh, MBVB prime squared. Actually, again, good now, prime. Sorry, guys. So many little things that we are missing out on, that I am missing out on. Plus 1/2 kx squared for the elastic potential energy. And then let's replace what we can para there's less unknowns in the equation. So uh, MB is 10 kilograms, 9.81. Tapos we establish that H in this case, since for every change in the height of B, for every change in basta for every change in XA, there's twice as much change in YB. So XA is 0.5 meters. So the change in the height of B is gonna be 1. So since we said kanina we're gonna set the datum at the ending ng B, our H here is just gonna be the change in Y. H equals change in Y. Then plus mu K. Yeah, so we don't actually use mu S in this problem, so they're probably gonna do that also in the exam, like give you both coefficients. You should know which one to use. So use mu K because A is sliding na, so it's, yeah, kinetic. Wala, di na naman nag-update. Um, Diyos ko po. Diyos ko po. What the hell? Ayun. Okay. Times the normal force. So we established kanina the normal force here. On the y-axis is just the weight and the normal force. So let's just replace it with the weight of A, which is, what is the weight of A? 5 kilograms. Oh, why did I put units? I mean, obviously, okay naman mag-units, but we're saving space. 5 times 9.81. And then the dot product with D, since we established kanina the friction is going to the right, but the displacement is to the friction is going to the left, but the displacement is to the right. So let's make this a negative, negative 0.5 meters equals 1/2 times 5 kilograms. And then since we're looking for oh my God, it stopped again. Ugh, what the fudge? This is so homophobic. Okay. Um, where was we? Okay, so 1/2 times the mass of A, and then we're looking for the velocity of block B. So if we just want to have a convenient life, the one that we're gonna replace is VA. So we want to find out what is VA in terms of VB. We established kanina VB equals to VA. So VA is equal to 1/2 VB. So let's just make this instead of VA 1/2 VB prime squared plus 1/2, and then what's this? Mass of B 10 times v prime b vb prime squared plus 1/2 k, which is 20, and then x squared 0.5 squared. Um, Shift solve nyo lang yan. You're gonna get 4.04 meters per second is gonna be the velocity of block B at the instant when block A has moved 50 centimeters to the right. Express your answers in meters per second. And then, yeah, sig figs is 3. Any questions? If there are no questions for 30 seconds, I will move on. I'll zoom out a bit if you guys want to see the whole problem. I'm not actually counting. I'm just guessing how long 30 seconds is. What is my rating ability? Huh. Okay, problem three. Let's read problem three. Who wants to read problem three? Anyway, a 1.2 kilogram block A is moving rightward at a constant velocity v v naught on a frictionless track, where it collides with a stationary 800-gram block B, which is initially located directly below the center of the looped section of the truck, with rho, excuse me, rho equals 40 centimeters. Block B suddenly moves with a rightward velocity of 4 meters per second and then goes up toward the top of the loop. Note that the coefficient of restitution between blocks A and B is 0.8. Find the velocity of block A right before it collides with block B. And then after block A collides with block B, will block B be able to complete the loop without falling off it? Explain. Um, yeah. So let's just jump right into it. So this is conservation of momentum, and like kaya nga sinasabi ko, like this topic is kind of easy because if you notice here, our collision with block A and block B, oops, it's just gonna be like this. And this is a tangent, this is the normal. So the normal line of the collision is already like in the direction of the velocity of A. So like we're very chill for this episode. And then so that means like there's not really anything going on the tangent line. So we don't even need to write the equations for that. So along the normal, MAVA plus MB VB equals MAVA prime. Oops. Plus MBVB prime. Then it's the block B starts at rest. Then we know also na BB prime equals 4 meters per second to the right. And then we also gave us that coefficient of substitution is 0.8. So E equals 0.8 equals VB prime minus VA prime all over VA minus VB. Okay. Ano gagawin? Damn it. Um, so let's make this VB prime minus VA prime equals 0.8 VA minus VB. Then we already know VB prime, so let's just put it there. Put her there. 4 minus VA. Whew. And then we also know that VB is 0. So we have an equation for VA prime in terms of VA or vice versa. Versa. Anyway, uh, let's substitute. Since we're looking right now, we're looking for the velocity of block A. So let's substitute. Let's find. Oh, we're looking for its velocity right before. So that's VA and not prime. So let's find VA prime in terms of VA so that we can substitute and eliminate VA prime muna. But later we're gonna need it again. So, oh sorry, baliktad. VA prime is equal to 4 minus 0.8 VA. Yun na yun, transpose. And then let's substitute everything we know into this conservation equation. Who, who loves conservatives? Anyway, 1.2 times, and then VA equals 1.2 times 4 minus 0.8 VA plus 0.8 times minute 4 meters per second. Um, well, yes. Okay. So, i-shift solve niya yan. Let me check, make sure I wrote it right. Yep. So if you shift solve that, you're gonna get VA is 3.70 meters per second, and like wala naman tayong like strange direction. So this is just to the right. Hooray! Letter B. We are so near the end. Like, I'm so glad we went on this journey together, everyone. Anyway, after block A collides with block B, will block B be able to complete the loop without falling off it? Explain. Oh, so actually, I'm a liar. We don't even need VA prime. Sorry, my bad. But we won't need it. Anyway, so after block A collides with block B, will block B be able to complete the loop without falling off it? Explain. So, um, sa mga nagka-cut sa inyo, maybe there's a problem like this during class. I mean, I actually I don't think everyone here is the same section as, same lecture section. May nag-chat ba? Oh, okay. Uh, so this is the loop. So when you're asked about like, is it gonna fall? Oh my God, what is this? Oh my God, I don't know how to draw a circle, guys. That's good enough. So, um, sabi nga ni Sir Matthew Travis Alcantara, we engineer things to fail. So, if we want to find out, um, if it'll be able to complete the loop without falling off, we have to find like the extreme, extreme as in parang minimum conditions for it to fall, because then that's what we don't like. So, when when would it fall, if ever? Or like, saan yung pinaka, like, what is the worst na pagdadaanan niya? It's the top of the loop. I wish the top of the loop was the worst na pagdadaanan ko. Anyway, so this is B. So we have to consider its situation up here at the top of the loop. So let's make the free body diagram. So it's just gonna be its weight and then its normal force. So ang point. So you guys know how like circular motion works? That's actually like there's like the centripetal acceleration, which is yes. Sorry, I don't know. I lost my train of thought. So basically, let's summate the forces first. So it's just sum along y is um n plus w. Let's just pretend that like downward is positive because you just need to be consistent. And then this is gonna be equal to MAC since centripetal acceleration lang ang present. Yeah, in this situation, there's just centripetal acceleration. That's the only acceleration of the block. So AC, if you remember, is equal to V squared over R. So um N plus W equals to the mass of block B times velocity, let's say prime prime of block B, yung velocity nasa taas, all over R. Or in this case, R is denoted as rho because like feel lang nila. They're just like that. Anyway, so what we want to do now is, since we have all this, uh, oh sorry, forgot to mention. Basically, yung point ng problem is if it's still on the loop, dapat normal force is greater than 0. But in this case, parang actually there's two ways to solve for this kasi. Uh, I mean, depende sa situation. But for this specific problem, there's two ways to solve for it. You can find the velocity such that n equals 0 and then see if enough yung velocity niya, enough yung magiging velocity niya. Or we can just find the actual velocity and then plug in our values to this equation and see what ends up being the value of n. What matters then is if it's not gonna fall, the normal force is greater than 0 because contact, contact force. Yes. So pag walang normal force, walang contact, which means it already fell off of the loop. Gets niya ba ako? And like, yeah, sometimes or sometimes there's a chance that if you plug it in, the normal force is gonna end up negative, which doesn't make sense because that means it's going the other way, which it's not. So that just means there's no normal force. So yeah, sometimes don't just believe in the numbers. Don't forget like to interpret them or whatever, stuff like that. So I think the easier, I don't know. They're just the same. But what I did is I solved for the actual velocity at the top na lang, since we're already given the the velocity when it started going up. So basically, we're just gonna find the conservation of the work energy of block B as it goes up the loop. So 1/2 mb vb plus mgh1 equals 1/2 mb vb prime prime. And actually, at the start of this an interaction, the initial velocity is what we solved kanina, the vb prime. Or not, we didn't solve pala. It's given. The 4 meters per second. And then plus mgh2. So h2 is just gonna be the height of this. We know the radius is point 0.4, so the height is just point 0.8. Point 0.4, yeah. 40 centimeters is point 0.4 meters. And then, so let's just make our datum the floor 0, so walang mgh at the start. So we're gonna get 1/2 times, ooh, 0.8 kilograms times 4 meters per second equals 1/2 0.8 kilograms. And then VB prime prime, which is what we want to find out. I sorry, squared. 1/2 MB squared. Square all that. Square it all. Square them. Guards. Sorry. Anyway, 0. Sorry, it's MB. 0.8 times 9.81. And the height is 0.8 also. And then shift solve to your heart's content. I'm just double checking if the formula, the equation I wrote is correct. And VB squared 0.8. Okay. VB prime prime, you're gonna find is equal to 0.5514 meters per second. So what we want to do now is plug in that VB prime prime to here. Oops. What the? Okay. So let's just put in everything we know na. Or actually, let's transpose solve so that we're solving for n, and then substitute everything we know. So MB 0.8 times 0.5114 squared all over rho, which is 0.4 minus weight, in this case, weight of B, so 0.8 kilograms times 9.81. So when you plug this in, you're gonna get for N na allegedly N is equal to negative 7.24 newtons. But that doesn't make sense because we're already sure na N should be downwards. Because I remember parang in module 1, unit 1, when you ABC, pag negative, that means the assumed direction is opposite. But in this case, that's impossible because we know na normal force should be normal to the surface. So this just means there is no normal force. So, um, and N is not greater than 0. So the block does not, oops, d- does not complete the loop as it is no longer in contact. So, yeah, or like what is the word? It breaks contact. It loses contact with the loop. Yun na yun, guys. Like, so easy. Are we all getting 100 in module DEF? Pero I'm not even 100 in ABC. Anyway, that's all. That's all we have for today. Um, any questions? Since we have a lot of time, like If you guys have like a problem you want to solve, pwede rin naman. But if ayaw niya na sa akin, go lang. Send a heart if you're happy with what you've experienced today and you're ready to go about the rest of your day. Oh, okay. Thank you for the heart. Okay. Um, yeah. PMs, you? Anything else?
Uh, well, I guess thank you. Thank you for showing up, guys. I guess siguro, yan, Joey sent the feedback form. Please answer the feedback form kasi that's how we track